Today's lecture, I want to go over the new lab that we're going to start next week, the 4140 steel processing lab. So we're going to go over that now that we're wrapping up the glass lab. So I want to go over that, and the things that I want to cover today is we're going to kind of go through the handout that I gave you for this lab, just like I did for the glass lab. You can see here, if you scroll down in the modules section of the course, you can see I also made put together some information here. So you can click and we'll go over the handout and what's involved in it and how it will be laid out. And then I'll show you some of the videos that are already up in the lab progress sheet, linked in the lab progress sheet. And then I want to go through a quick set of slides that will kind of introduce you to some of these experimental procedures that we're doing in this lab because we will have a job safety analysis sheet for the steel lab. So I've actually moved it back. So it was originally due before the lab started. I've now moved it to the end of the first week. So that would be Sunday, March 7th at the end of the day. So 11:59. So that's moved back just because I wanted to give you a little extra time. But the slides I'm going to show are going to kind of show you all the tasks that we're doing for the steel lab, which hopefully will help you a little bit think about what the safety considerations will be. So that's kind of what I want to do. I want to go over the handout and the basics of the lab and assignments and so forth, and then move on and show you the slides and show you, kind of help you get ready for the job safety analysis. All right, so let's go ahead and get started. And again, this is the module page, so experiment 2. So you can find all the handouts and literature that you may need here. And then also we have our share drive, which you can find data and so forth. So let's go to the handout, because that's going to be your first stop that you want to go to. So the first thing you might notice is there's actually 2 groups. There's 2 experiments happening. So if you're in groups 1 and 2, you'll be doing what we call the quenching and tempering experiment. And then groups 3 and 4 will do the isothermal transformations. So these groups that you set up at the beginning of the semester, those are the groups that I'm talking about. So you're not responsible for both experiments. If you're assigned to one, that's all you have to work with. You have to work and analyze through the quenching and tempering group if you're in groups 1 or 2. And then you will also report on those activities. So limit your focus. We're not kind of sharing between the groups. Groups 1 and 2 can work together. Groups 3 and 4 can work together, but you don't have to incorporate the other groups' experiment. You just have to report on your own. So make sure that's clear. All right, so let's continue to just kind of look through. So I've got some objectives here. And as you're probably familiar, some of these are going to be kind of a little bit adjusted because we are doing mostly remote. Although we will again have in-persons throughout the semester for people that are interested in doing that. Background. Some of these you may have already read portions of. I'm not exactly sure what Metal's book that you guys are using these days, but the one that I used when I taught it is Physical Metallurgy by Reed Hill. And so there's some important chapters, and I believe all of this is in Canvas that you can take a look at if you don't have those specific volumes. So that's some background information, and I tried to identify which chapters were useful for which groups, so you can kind of go through there and get some background on these experiments. You can look through the equipment and so forth that we have, but again, the main thing is that groups 1 and 2 will be doing the quenching and tempering, and groups 3 and 4 will be doing the isothermal transformations of 4140 steel. So the rest of the handout is mostly about the procedure. So in this case, we're doing kind of a preset experiment on quenching and tempering or on isothermal transformations. And so I have a pretty detailed list of procedure steps that we follow when we do this lab. And so you can go through and look at what all of that is, and this can be something that you look at while you're looking at the instructional videos for the given components. So you'll see that that matches up pretty well. So for example, it says that the samples are austenitized. So if we go over to the lab progress document, and again, you start with the glass lab, but if we scroll down to the 4140 steel lab, you'll see that I have it again divided by weeks. I have the assignment, which again is due Sunday, March 7th. And then there's an austenitizing heat treatment video. And so if you click on that, that will give you the link that covers the austenitizing heat treatment process, and also gives you some information on furnace safety that could be helpful for your JSA. And then there's other ones as well. So quenching, tempering, isothermal transformations, oxide removal, and hardness testing. All of those videos are already available to you. And so you can look at those as you progress through the material. So again, as you go through this, you'll probably see things like that, austenitizing or quenching here. That talks about quenching here. There's a video for that. And so those videos are meant to kind of correspond to the techniques that you're using in the procedure. And we're progressing through this, based on weeks. So the first, as you can kind of see from the breakdown here, the first week is going to be mostly heat treatments, but we'll have hardness testing as well. And there's actually already data for that. And so if you click on those, it'll take you to the links for the data, the hardness data for your experiment. So Q and T stands for quenching and tempering. ISO stands for the isothermal transformations. And so that's the breakdown for all of the results that you're going to see. And again, that's in your share drive. I'll try to link it as much as possible, but you can always just go to our class share drive to find that information. All right, so that's basically, again, the handout is going to be your first kind of place to go to find all the steps, and then follow along with the videos that I'm giving you, because again, we're not going to be in the lab quite as much this semester, and so those videos are meant to kind of show you exactly how we're doing those individual steps. So that's the again, and so let's if we go back up here, again, this was for the quenching and tempering. So there's a whole procedure set for that. And then if you keep scrolling, you'll see that it ends. And then there's another procedure set for the isothermal transformation. So again, you're only responsible for whatever group you're in. So make sure that you keep in mind that. I will say amongst your groups, so 3 and 4 can work together and divide task up to make it go faster. So feel free to do that. Not everybody has to do all of the analysis. If everybody's working together, they can kind of split up the task and do it that way. So, make it easier on yourself in terms of that with working with your groups. But you'll see the same kind of procedure steps, but obviously different for the isothermal transformations. And I try to go in more detail in the videos to show you how these are done along with the procedure steps that you see here. So that's what we're going to do, and we're going to follow this as we go through the week. So like I said, the first week is the heat treatments and hardness testing. The second week will be tensile testing and resonance testing, and then the last week will be on metallography, so grinding, sectioning, polishing, and then microscopy. So that's kind of how we're breaking up the material, and I'll try to have as much done in advance as possible. So if you get done or you're ahead in the week, you can always go ahead and look at the next week's information. So I'll try to get that as much as possible. And you'll also notice that the first worksheet isn't due until the end of the second week. This works out well because the compositional analysis for the first experiment, the glass lab, is running behind. So we're actually having to kind of double dip in this week here. So that's good. I don't want too many things due for that. So you'll have a little extra time to work on that, but you will have 2 worksheets after the second week and after the third week in terms of this lab. All right, so now let's go over and switch to the slides and discuss the task in a little bit more detail so that you can start putting together the JSA for the steel lab. All right, so this brief slideshow is meant to show you the task that we're going to be doing for this 4140 steel processing lab in order to get ready and complete your job safety analysis, so your JSA. So it's often hard to think about all of these tasks without actually having done them before, and so I put together the slideshow, and also you'll have the instructional videos that I've linked from YouTube for most of these tasks already. So all of that information is going to be available for you as you write these JSAs. Okay, so here's just a summary of the various tasks or jobs, or whatever you want to call them, for the steel lab. And so the first one is furnaces, working with furnaces, transferring steel, right? So all of our samples are austenitized at 850 in a box furnace, and then transferred to something else. And so we'll talk more about that. After that, or at some point, we clean off the oxide, or basically after all of the heat treatments are done, we'll clean off the oxide scale from the steel. We'll talk about more of that as well. We also have hardness testing, which you've done before. We have resonance testing, which is probably new to you all. And then we have tensile testing, which you've done before, maybe with a slight iteration here for our experiment. And then we have grinding, polishing, etching, and so forth. So basically metallography, right? So all of those tasks. And so I just want to walk you through these so you have a better idea of what the potential hazards and safety considerations will be. So let's start with the first one. So the heat treatments are different depending on which group you're in, whether quenching and tempering or the isothermal transformations. But the possibilities are that you transfer your steel from the austenitizing furnace either to another box furnace directly, and those temperatures are from anywhere from 200 to 700. It could also be another furnace containing a molten salt, if it's labeled as salt pot. And then it could also be directly quenched in room temperature quench oil. So those are kind of the possibilities that we have. And with each of those, you also have to consider removing the samples from those vessels. All right, so those are the kind of different transfers that we have. And so there are videos on the austenitizing process, on tempering steps, on quenching, on the isothermal transformations. So there's going to be videos already up that show those in a lot more detail. The next step after we finish these heat treatments is that these are all done in oxide containing environments, and so they all oxidize and produce a scale. And so we need to remove that for future tests. And so the way you do this, and you see this in the videos as well, is that we basically place our sample in a set of vice grips to secure it so we don't have to hold it. And then we use a wire brush, either as on a Dremel tool, and we also have a drill. That's what I was using in the instructional video. Either way, you use that rotating wire wheel to remove the scale, as you can kind of see the person in this video doing. So that's how we remove the scale that becomes part of our sample during the furnace treatments. All right, hardness testing, I don't go over much of that, but just because I think everybody's done that before. But basically, Rockwell hardness testing, and we do that on the tensile dog bones shoulders that have been cleaned off of any possible oxide. We also have impulse excitation, or what I call resonance testing, which has a similar setup to this, where we basically have a microphone, this kind of impact hammer. We have our sample. Here it's concrete, but we actually use our steel samples. And then you have electronics to measure the frequency of the vibration of the sample. And so that's hooked up to a computer as well. There's a separate handout for this. And then in week 2, we'll have a video over this setup as well. So you can see any potential hazards, if there is any, for this test. You're all familiar with tensile testing as well. We will do tensile testing on the steel samples, and then so you'll probably already have that information, but there's going to be videos on it. And then any alterations that we do from what you've done in, say, MSE 202, we'll also discuss and potentially have videos on how to use that. And then everybody's favorite, metallography. So we'll be grinding our steel samples after they've been mounted, right? So they get cut with a cutoff saw, and then they get mounted in either epoxy or acrylic. And then we're ready for grinding, which you're familiar with, kind of our operation here on the grinding wheels to do that. And then we polish, which is more or less the same activity with just different materials. And then we have etching. With our etchant, 2% nitol is what we use in this lab in particular, which gives us grain boundary contrast, phase and grain boundary contrast. And so you've probably done this in other classes as well. And then you're familiar with the optical microscopy to obtain images of the microstructure. And so that will all be similar to what you've done in the past. So a lot of this you've done before. I have videos, some that I've produced and some that Nancy has produced for 202 because they're the same task. And then I'll put any alterations that we do. I'll make sure that those are clearly known to you. But again, this slideshow was just to kind of give you a sense of the different tasks that we do for this lab, and then that starts to stimulate your thoughts on what each involves and the hazards and safety considerations that we need to look at for the JSA assignment that's due at the end of the first week. So again, this was just to kind of get you ready for the steel lab, which we will start next week. And so we have that JSA, and then we'll have worksheet 1 due at the end of the second week of the steel lab for that. So yeah, this hopefully has helped you get ready for that. And then stay tuned for updates, and make sure you're checking the share folder for incoming data for this lab.